There is no more hostile place to life than the empty expanse of space. Regrettably, it makes up virtually the entire universe. So how do we go about living there? So today's topic is focused on living in space, and at first that might sound like familiar territory to us, as we've discussed colonizing space a lot on this channel. But in point of fact, we generally don't talk much about living in space, but rather how to colonize planets or moons in it, which is no more colonizing space than living on islands is colonizing the ocean. Even when we discuss building artificial habitats there, our topic for next week, that's still mostly about making as Earth-like a place as possible. There's a big difference between terraforming a place to be Earth-like and actually adapting in part to that environment. Consider 3 scenarios. Folks decide to make their home on the coast of Antarctica. In one scenario, they drag down some fission reactors and a lot of glass, dome the place over and provide supplemental lighting and heating so they could walk around inside in t-shirts and shorts. That's essentially terraforming, and one can argue that regardless of address, those folks don't really live in Antarctica. In the second scenario, they visit some high-tech genetics or cybernetics lab that changes them and their children so they can walk around in the natural Antarctic environment as comfortably as a penguin, and that's what we call bioforming instead of terraforming. That's been discussed for planets, but not so much for actual space itself. I've mentioned the notion of void ecology in passing before, the notion of creating life forms designed for living in space itself, and how you'd probably need to start from the ground up and blur the line on what we normally call life to achieve it, and we'll talk about it more down the road a bit. Our third scenario is that middle ground, and something humanity has done a lot of, where we change ourselves a bit and we change our environment a bit, but mostly we adopt a new way of life to fit that environment. And that's more of our focus for today. We've talked a lot about the technology that makes it possible to colonize planets or make the spaceships to get there, but not too much about the change in lifestyle. We've got some good examples of that in fiction to look at for inspiration, and one of those comes from our SFIA Book of the Month, sponsored by Audible, Leviathan Wakes. This is the first book in the Expanse series, which obviously inspired today's episode title. The books have gone on to be adapted into a very good TV series just starting its 3rd season. The novel focuses a lot on the culture that you see emerging both in the asteroid belt, where no realistic terraforming is really viable, and on the people who spend their lives on spaceships, and how these environments fundamentally alter their lifestyle, culture, and outlook on the universe. It's a great novel, and you can pick up a free copy of Leviathan Wakes today and also get a 30-day trial of Audible. Just use my link, audible.com/Isaac, or text Isaac to 500-500. We're going to be spending a lot of time this year looking at some scenarios for humanity's future, and this seemed like a good place to start. What defines a culture in many ways is not what it has in abundance, which does surely shape them, but also what they have very little of. When we move into discussing post-scarcity civilizations in a month or so, civilizations defined by lacking virtually nothing, we'll see that it isn't entirely true, and they can lack things like a sense of purpose or privacy. Conversely, early explorers and settlers in space definitely do not lack a purpose. If you're going off to colonize Mars or Ceres or haul comets to water-starved locations, you clearly have a major driving purpose. And this is space we're talking about, and this is why life in space is a good place to begin our discussion of future human civilizations. You lack virtually everything you need to live there. Space is huge and empty, even on a desert planet like Arrakis in Frank Herbert's Dune novels, where water is so scarce they recycle their dead. They still have air to breathe freely. Dune's another great example of this in science fiction too, as Frank Herbert explores the huge impact that water scarcity has on every facet of the inhabitants' lives. He shows us a great dichotomy of scarcity and abundance in that novel too. On Arrakis, they have no water, something vastly abundant almost everywhere else, yet they have easy access to the spice melange, a substance so precious elsewhere in their empire that a pocket full of the stuff would let you live a life of luxury on the planet of your choosing. This is a good example because one of the biggest driving forces for colonizing the solar system, especially the asteroids, is that you could potentially bring home tons of precious metals. One tiny mining party of a dozen people might go to an asteroid and mine it and come home with a cargo hold packed full of thousands of tons of gold or platinum or lanthanum, each valued at about $60,000 a kilogram right now, and thus land on Earth with enough assets to make each crew member a billionaire a few times over again, even if the mission cost billions to launch. Now, to state the obvious, that's an unstable profit margin, and it wouldn't be long before market prices for those commodities dropped to just over the cost to conduct such a mission, though a 1% profit margin to a crew on a multi-billion-dollar expedition is nothing to sneeze at. Of course, there's no guarantee they'd be paid that either. Historically, regardless of what you mined, you got paid about the same, and usually not terribly well at that. One man swinging a pickaxe might be much like another. The salary only has to be attractive enough to outweigh the hardships and risks involved compared to some other job, assuming you even paid them. Mining has a fairly bad reputation even by the fairly low standards of labor historically, and of course we see that in science fiction a lot too. But regardless of the value of some precious metals in your cargo hold, when that vessel is a spaceship, you trade all of it for some fuel, water, or air if you're running low on them, and you need to give over valuable cargo space to those if you want to finish your journey. Again, nothing new there. Ocean-going vessels carrying ultra-valuable spices still needed to carry food and water, and nobody ever missed the irony of sailors of old needing barrels of water while sitting on a literal ocean of it. That's an entire culture, indeed several, revolving around sailors, so there seems no reason we wouldn't expect the same of those serving on spaceships. This same would be true of mining operations, though our focus today is more about life on ships. One thing they have in common is that everyone is going to be very mindful of who's managing the water and air or any damage to the structure and machinery managing those, and keeping them contained in that little bubble of life surrounded by the infinite void. We see that in the novel Leviathan Wakes as well. The residents of those asteroids consider anyone tampering with life support to be essentially committing a capital crime, a point made in the show too, but not emphasized quite as much. They do make a couple of errors though. First, water as a raw material isn't something an asteroid colony on Ceres would ever lack, nor any place much further out. Once you get out to Jupiter and beyond the frost line, we get reminded that the first and third most common elements in the universe are hydrogen and oxygen. H2O is essentially the most common molecule in the universe, after molecular hydrogen, since helium doesn't bond to anything. Like all noble gases, it's very aristocratic and snobby. The other big one being that Ceres was spun up for more gravity, one of the big engineering accomplishments of Tycho Station, another being the Nauvoo, a generation ship with a rotating interior similar to the O'Neill cylinders we'll be looking at next week. That path works fine, but spinning an asteroid to generate more gravity does not. Ceres is the largest asteroid out there, and while there are over 1 million asteroids in the belt, Ceres has fully 1/3 of the belt's mass in it, enough that it's actually a dwarf planet like Pluto. In spite of that, it would take 6,000 clones of Ceres to equal the mass of Earth, and surface gravity is only 3% of Earth normal. So you'd want more gravity there, and certainly on any asteroid habitat, as even for most decent-sized asteroids, the gravity is so small you could jump off one and never fall back down again. However, you can't fix that by spinning one, and indeed if you did opt to change the rotational rate of an asteroid, it would usually be to slow it down. Most rotate a good deal faster than Earth, and Ceres does so every 9 hours. But they aren't rotating very fast in terms of speed, which is good because if they did, they'd fly apart. The faster you spin something, the more centrifugal force it experiences, and as we discussed many times on the channel, you can use that as artificial gravity. However, it is gravity that points outward from the spin axis, meaning the poles experience no change while the equator gets the most spin gravity. The problem is, that artificial gravity is in the opposite direction of actual gravity. It's flinging you away from the planet, moon, or asteroid, not pulling you in. That's why we'd say we'd live on a planet, but we say we would live inside a rotating habitat. You're not adding to Ceres' gravity by spinning it, you're decreasing it. Indeed, that's one of the tricks we've discussed for making high-gravity planets easier to live, or orbital rings around gas giants or other supermassive astronomical bodies. People occasionally talk about hollowing an asteroid out, then spinning it and living in it, but that's a bit backwards too. Your typical asteroid is nothing but a loosely held together ball of gravel. Give it an Earth's gravity worth of spin and it will fly apart. Other than that, the basic concept is fine. You can hollow an asteroid out and not spin it, and instead stick a rotating habitat inside it, whose sides are high tensile strength material, not a wad of gravel. And it's a very good place to put one, again our topic for next week. The right way to do it for a place like Ceres would be to drill holes down all over the asteroid like a golf ball's dimples, only deeper, and put in cylinder habitats in those holes, pointing down. Then, if you wanted to, you could dome over that with glass and drop the plant's spin down to once every 24 hours. However, while on this channel we tend to casually discuss manufacturing things the size of planets, it is worth noting that doing so requires insane amounts of manpower, or at least robots. I tend to expect that we will have very good robots before we are seriously colonizing space, but that's hardly guaranteed. Even then, for any given construction project, there are limitations, even if only because you can think of other things you'd like to do with those resources and manpower. In theory, I could build a greenhouse over my entire backyard. In practice, I have one that's 12 foot by 20, and I tend to feel I went a little excessive just doing that, especially on occasions I find myself having to perform hasty maintenance on it in foul weather. Maintenance is even less pleasant in space, where there is nothing, except for lethal levels of radiation and the occasional hypervelocity micro-meteor. For any given habitat in space, there is going to be a line where people say, this is quite enough. Where they draw it will of course depend on what the minimum they need is, and the most they can afford, and will settle somewhere in between, but likely much closer to the minimum in the early days in space. That's even more true of spaceships, since how fast they can go is controlled by how massive they are. You might be able to build several acres of forest on a ship, but someone is bound to ask if something smaller can do the job, since it means your trips are shorter or carry more goods. This is likely to be particularly true of more high-tech civilizations, as someone is likely to point out that some virtual reality setup is likely to be way cheaper and provide all the landscapes you want. How far you can push something like that depends on what the acceptable norms are, and again those get sculpted by the pressing needs and stresses of your local civilization. We often see discussion of whether or not space colonies would be vegetarian due to efficiency needs, but even that might be not looking far enough. There's a lot of old sci-fi where you'd see people eat meal capsules, swallowing some vitamin-sized pill that was apparently a whole meal, and that's quite unrealistic of course. As we noted last episode in Portable Power, fats, carbs, and proteins aren't as energy dense as, say, gasoline, but not by so much that you could get all of your calories out of a pill-sized object, even if you could metabolize hydrocarbons for all of your nutrient needs. On the other hand, plants themselves aren't that efficient at converting energy into calories, and not terribly fast either, and we could easily see food production in space shift to some genetically tailored algae or even carbs, proteins, and fats that were made artificially. You can make those in a beaker after all, no plant or animal is required. You might see everyone in space eating some carefully synthesized gruel with artificial taste added, or even folks getting tongue implants that just simulated the taste, even augmented reality overlays that made you feel like you were eating a 7-course meal instead of algae paste. Throw in a bit of peer pressure and you could have folks continue to eat that way long after their settlement could easily provide more classic cuisine just because that's how they do things and only weak, soft individuals need more. That's how we do things still remains an amazingly common and successful argument, even nowadays when our civilization is dependent on ever-changing and improving technology, and we actually have reliable historical accounts going back long enough to tell us that we haven't always done things that way, so I would imagine it will continue being a common argument in the future too. That could apply to a lot of stuff. We don't know yet how much gravity is enough for a human to live healthily. Our only data is from Earth and zero gravity in orbit, and odds are good we can handle a lot lower gravity than Earth's. Further, we'd expect technology to lower that safe amount even more as time goes on. artificial gravity is expensive, and the more you want, the more expensive it is. We can only do this by spin, which requires pretty big devices. The more gravity you want, the bigger and stronger that outer spinning shell needs to be, or by constant acceleration, a very popular application in fiction, including in the Expanse, but also one that really only makes sense with some sort of infinite fuel source, or for very specific set distances. Outside of a fairly narrow range, you wouldn't burn fuel that way. Most of the time you'd accelerate as fast as your crew and ship can handle, then drift, because it shortens the voyage time to do it that way, and because it makes no sense with a reaction drive to accelerate all the way to the moment you flip over and decelerate, because most of that fuel you used in the middle is basically wasted. It's like flooring your engine on the way to a red light. If you accelerate at 1g for 1 day, then flip over and decelerate, you will have covered 75 million kilometers, reaching a peak speed of 847 kilometers per second. If instead you accelerated at 4g for a quarter of a day, you will reach that same speed of 847 kilometers per second after 6 hours, having covered just 9 million kilometers so far, and you'll cover the same in your last 6 hours decelerating at 4g. However, the 1g ship was moving for 2 days. We only did half a day up and down with the 4g ship, so it's got 36 more hours drifting at 847 kilometers per second. During that time, it will cover 110 million kilometers, not the 75 the other ship did, plus the 9 million each up and down. 128 million kilometers versus 75. That's 70% more distance covered, in the same time with the same fuel. It just burned it faster. So which way do you think folks would go? To add to that, the best defense a ship has against space debris or weapons is the ability to suddenly apply thrust in a random direction if being shot at, and the more, the better. When that happens, the direction of apparent gravity will suddenly and violently change direction. Just like low but non-zero gravity, we don't have great data on the long-term effects of high gravity on people, but we have exposed human subjects to 1.5g for as much as 7 days without ill effect, and you can even walk around in that, you just get tired. It might not sound like a big difference over 1g, but it would make more than a big enough difference that anyone not flying for recreation would do it when they could, and just switch over to spin gravity when they finished their initial burn, even though that meant needing to swap around where the floor was compared to the wall. So it isn't that you'd expect people to adapt to lower gravity so much as they'd adapt to changing gravity, and likely as much as they can safely tolerate, at least those working and living on ships, and that would alter everything about day-to-day life. We tend to put weights and grips on the bottoms of cups on sea vessels because they rock around and you don't want them spilling or sliding. Suction cups see a fair amount of use too, and probably would see more on a spaceship. You tend to want to have padding on everything, tethers connecting stuff, and things that couldn't spill. What's more, you might put airbags in the walls or uniforms people wore, because if a ship suddenly detects an object it needs to slam on the gas to avoid, odds are that will be a computer doing it for minimum reaction time, deciding it has no choice but to do it or lose the ship. No warning to grab stuff, just some siren blasting out to tell you not to prepare to fall, but that you are already doing so. And falling even a couple meters at several times Earth gravity is going to hurt you bad, potentially kill you, and any sharp or hard object nearby could come whipping into you like a sword or a sledgehammer. Odds are good every chair, bench, and bed on that ship is an acceleration couch and has belts and buckles on it. Most of us habitually fasten our seatbelt when we get into a car these days. I'm old enough to remember when people found the chest belt irritating and would just do the lap belt, and even then a lot of folks griped about either. Some folks still do, but to most of us it's not just a habit, we actually feel uncomfortable until we have it on. I would say they'd probably get to be the same way, except I tend to expect those to be smart chairs that could cocoon you in an eye blink instead. Barring that, remember it's not just strapping in on your chair in the bridge. It's not just doing so in the ship's mess for a cup or bulb of coffee and some donut-flavored squeeze paste. It's in the bed, and it would be in the bathroom, except I wouldn't be surprised if most ships don't actually have one. And I don't mean because you can't have a hot water shower in space, that water shortage notion is a holdover of modern tech. No spaceship pulling hours or days of high-G acceleration could give a fig if its crew members felt like taking blisteringly hot, hour-long showers every day, because that water limit has to do with needing energy to recycle that water, and compared to the energy output of the ship's engines, their water recycling energy use is going to look like a rounding error. Rather, it's that you probably won't spend much time outside of your clothes, and there'd be a lot of push to make spacesuits able to be comfortably worn 24/7 that could recycle everything for you, including all your bodily waste, akin to the still suits we see in the novel Dune. That would have a pretty big impact on your lifestyle and subculture too. I could easily see a basic ship suit being the equivalent of a second skin you rarely and maybe even never took off. Anyway, energy is not scarce for anything but the ship's engine and speed, because that is so huge compared to any other energy need. We said earlier that both what is abundant and what is scarce is what drives a culture or subculture's mindset. On a ship, the abundance is energy, because they burn fuel at insane rates, and they can't realistically do anything on that ship that is going to make it really matter if they are soberly efficient or drunkenly wasteful with their juice. There's not much they can use it on either. An interplanetary cargo ship, one past an era of chemical fuels, will not bother growing plants on board because they can recycle their air and water mechanically instead, and ditch waste if they need to. Recreation is unlikely to be a big energy soak, and a hydroponic system is not going to handle sudden changes in gravity strength and direction very well, and serves little point on some fusion-driven ship that is unlikely to ever be out for more than a month at a time before they can resupply. So at most, they might keep seed packets somewhere and the feedstock for a 3D printer to manufacture hydroponic equipment if they needed to, as seeds are ultra light, and odds are every ship would have a 3D printer. That's what is abundant. What's scarce? Air and water somewhat, but the big one for spaceships is mass. Mass is the big limiter for ships, not habitats. Every kilogram you have has to be pushed up to speed, so every extra bit of radiation shielding, every extra bit of additional reserve air and water, every extra object in your personal luggage, and maybe even every kilogram of fat or muscle on your body is slowing that ship down. So how does that affect mindset? It's not really space so much as mass, so a ship doesn't need to be tight quarters, but they wouldn't want you to fill up a spacious cabin with heavy gear either. You might be encouraged to wear your suit all the time just so they can cut down a little on the exterior radiation shielding, if that suit provides some. They're not going to appreciate you bringing your antique book collection along instead of digital copies. They might be okay with your fish tank though, since the water could be used as a reserve source. They won't want you having anything that isn't easily secured when not in active use, nothing that is going to fly off and kill someone when the wall suddenly becomes the floor. Light, strong, durable, minimal. Now how far that goes and in what directions is hard to say. Odds are every ship would have its own flavor too when it came to what they were very strict about or very relaxed about, but that's the sort of influences affecting the mindset we'd expect to see. Space is a murderous death pit empty of everything but radiation and tiny bits of super fast debris spraying around like shrapnel to kill your ship, millions of kilometers from any rescue, which is more likely to involve vacuuming up your remains than taking you back to a hospital. I suspect it would tend to encourage a pretty disciplined and serious mindset, less so for space habitats as we'll discuss next week. But our book of the month, Leviathan Wakes, is a great example of authors looking at the environment and crafting how it alters a society, not just physiologically, but culturally, creating its own priorities and customs. If you've seen the show, you know how good it is. And while I normally say the book is always better than the show, that's hard in this case because it really is an excellent book, but the show is so good. Let me instead say that while it is a very solid adaptation, there are quite a lot of differences and a lot more depth in certain areas, and I prefer the chief protagonist, Jim Horden, as depicted in the novel over the show. He still seems to get stuffed into every crisis going on in the solar system, but without that element of reckless lack of forethought the TV version sometimes seems to have. You can pick up a free copy of Leviathan Wakes today. Just use my link in the episode's description, audible.com/Isaac, or text Isaac to 500-500 to get a free book and a 30-day free trial. And that book is yours to keep, whether you stay on with Audible or not. And if you don't enjoy it, you can swap it out for a different book at any time. As mentioned, next week we will be looking more at space habitats with an episode on O'Neill cylinders, giant cylindrical habitats that we'll see are a lot more comfortable than life on a spaceship is likely to be. For alerts when that and other episodes come out, make sure to subscribe to the channel, and if you enjoyed this episode, hit the like button and share it with others. Until next time, thanks for watching and have a great week.